Hey guys, I'm back. I'm going to kind of show you some of the examples that we had on the inside of our notes. So this is still from 2-9 of 15. So in this case, if you notice at the top, we actually have two functions. So we have f of x is x squared plus 3. So I'm going to go ahead and write that there. So this is our function f, and we said on the front that we're going to name this Frankie. So Frankie, his function is x squared plus 3. Then I also have my friend George here. So George is this function. So if you notice that I have a g here, that just means that we have two different functions. Our first function we named f, our second function we're going to name g. And George's function is just x plus 1. Okay, now if you remember from the beginning, or on the first page, what we did was we took and we said, okay, f of 3. In this case, we took this x and we replaced it with a 3. So now I need to take this x and replace it with a 3. So if I show my work, I'm going to have x squared plus 3. Then I'm going to fill in, so now I'm going to have 3 squared plus 3. 3 squared plus 3 is equivalent to 9 plus 3, which equals 12. Now in this case, we're going to say y equals 12, and our ordered pair is our input, which is 3, and our output, which is 12. Pretty easy. We're going to go ahead and do the same thing, but this time if you notice, we're evaluating for g. So we substituted x for 3, so we're going to substitute 3 for x. So in this function, we have x plus 1, 3 plus 1. 3 plus 1 is the same as 4. So y equals 4. Our input is 3. Our output is 4. Simple as that. Same thing, f, negative 2. Negative 2 times a negative 2 is positive 4. Plus 3 is 7. So we got y equals 7. Our input is negative 2. Positive 7. Now we're on g. G is 0. 0 plus 1 is 1. Y equals 1. Input of 0. Output of 1. Pretty easy. Now when we get to this, all this is asking us to do is to evaluate Frankie at 2 and George at 1. So if I go ahead and we're going to go x squared plus 3. Substitute for 2 plus 3. Oops, I can't forget that squared. 2 times 2 is 4, plus 3 is 7. Then on my g, I'm going to substitute. So I have x plus 1. Substitute that 1. I get 2. In this case, all we're going to do is we're going to add. So 7 plus 2 is 9. We don't have a y equals in this case. It's just 9. Let's go ahead and do it again. This time we're evaluating for g first. So if I put in a negative 1 plus 1 is 0. If I put in a 1, 1 times 1 is 1, plus 3 is 3. When I add them together, I get 4. In this case right here, if you look, we actually have a situation where we're going to use order of operations. So we have g of 2 is in here first. So what this question is actually doing is evaluate the function f when your input is g evaluated at 2. So the first thing that we're going to do is evaluate g at 2. So 2 plus 1 is 3. Then we're going to evaluate the function of f at 3. So 3 squared is 9, plus 3 is 12. And we can say y equals 12. In this case, though, our input was actually g of 2. So we're going to have an ordered pair that looks like that. If we go ahead and do this again, this time we're going to evaluate f first. So 0 times 0 is 0 plus 3. So f of 0 equals 3. Then we're going to take g of 3. 3 plus 1 equals 4. So our ordered pair, y equals 4, and our ordered pair is f of 0, 4. Finally, right here, on all of these, what we did was we noticed that we are substituting x for this 3, so we throw 3 in here. Down here, the only difference is instead of a number, we have a variable. So we substituted x for y, so we're going to substitute y for x. So we end up getting y squared plus 3. Same thing with our g here. We've been substituting x for 3, so we substituted 3 for x here. So this time we're just going to do it with a w. So we're going to put a w right here, so we end up with w plus 1. Hope that helps. When you get ready to start doing, oops, and I forgot I taped it so I could write. When you get ready to start doing this question right here, notice that your function actually has x squared minus 3x. You have 2 x's here, so you need to plop this 5 in for both of these x's. Good luck, and let me know if you have any questions. You can always find me at Miss Ivey Jameson Ivey on Facebook. Hope you have a nice night.